Hello students, today we'll discuss in this video we'll discuss Ohm's law. And to understand Ohm's law, student, first of all try to understand this circuit. In this circuit we will use different number of cells and in different condition what reading of voltmeter ammeter we are getting, we'll discuss that one. Here assume this one is voltmeter and this one is the reading of ammeter. Ammeter, you know, that is used to measure the electric current, and voltmeter, you know, this is used to measure the voltage or the electric potential difference of the circuit. The students, first of all assume here only one cell has been used in this condition, and the cell is of 1.5 volt, and due to which the reading will be shown here 1.5 volt. And at that time situation, here suppose it is the reading of the ammeter is 75 milliampere. Here students, as soon as we'll use another cell, second cell, so what will be the condition? Here condition will become the voltage, reading of voltage will be 3 volt, and the reading of ammeter will be 150 milliampere. And student, in third case, now suppose we are using third cell, so 1 cell, 2 cell and 3 cell. So in this case the potential difference will be 4.5 volt and the reading of ammeter will be 225 ampere. So students, in this case, and as we will increase one more cell, that is the fourth cell. See here 1, 2, 3 and 4. Now the number of cell is 4. So in this case the potential difference will be 6 voltage, whereas the reading of ammeter will be 300 milliampere. So from this activity, student, what do we observe? We observe that electric current is directly proportional to voltage or the potential difference. That means if the potential difference will increase, the electric current will also increase, and if the potential difference will decrease, the electric current will also decrease. And in case potential difference is 0, the value of I will also be 0. So students, here if we are increasing the potential difference, the I will also increase, and if we are decreasing the potential difference or voltage, the current will also decrease. And in case of potential difference is 0, current will be also 0. So from this relation, that means at constant temperature the current flowing through a conductor is directly proportional. Current through the conductor is directly proportional to the potential difference across its ends. This is Ohm's law. This is Ohm's law, student. Now suppose we want to change this proportionality symbol and want to make an equation, we can write the same by changing this proportionality with a constant, and that constant we used to take R in Ohm's law, and this R is, student, resistance. This is resistance. And this resistance, what this resistance is, actually we can say this is the proportionality constant. This is proportionally constant. So this proportionality constant or resistance, we can also define this one as this resistance. We can define the property of a conductor due to which it opposes the flow of current through it is called resistance. To understand, student, we can draw it here. Suppose in a conductor, this is a conductor, when it is connected with a cell, what happens? The electric current from the negative terminal, it start to flow, and due to the electron, when we know that is inside a conductor, atoms as well as electrons are present. So when this electron starts flowing through this cell, due to the movement of this electron, the electron present in the conductor also get repelled, or due to it is repelled by the electron of the cell, and that's why it starts moving in a particular direction. So this starts moving in a particular direction, student. So this, when it starts moving, but because of the presence of atoms, it may be sometime electron also, so this presence of atoms, they get collide with it, and due to the collision of these atoms, they get opposed. So this opposition, actually this opposition to current we can say is the resistance. So what is the resistance? The opposition to current is, we can say, a resistance. And now students, this resistance, we can say this is a constant, a proportionality constant, and from the equation, this equation, that is the equation is V is equal to R into I, or IR, or I, this one we can write V by I is equal to R, or R is equal to V by I. So here this is resistance, student, and its SI unit of resistance is omega. It is ohm. It is ohms, and this ohm is represented by the symbol omega. So SI unit of resistance is ohms, and this ohm is represented by omega. Now here in this equation, R is resistance, V is potential difference, and I is electric current. So this constant, now from this equation we can write one thing, that unit, as we had discussed, the unit can also be defined one unit, like here first of all we'll write their unit. The unit of resistance is ohm equal to unit of potential difference is volt, and the unit of electric current is ampere. So from this relation we can define 1 ohm. What is 1 ohm? So student, last class we had discussed that first of all we'll write 1 before all this unit, and now we can define this 1 ohm. So how we'll define? From this equation, 1 ohm is the resistance of a conductor such that when a potential difference of 1 volt is applied to its ends, a current of 1 ampere flows through it. So 1 ohm is the resistance of the conductor such that when a potential difference of 1 volt is applied to its end and a current of 1 ampere flows through it. So thus we can